today the focus is on local LLMs. So we're gonna focus on the Ollama framework today. So what's Ollama? It's an open source framework that makes it easy to access local LLMs. So really, really simple. If you go on to ollama.ai, then you can see what they're doing, their blog, download and install the things, and their latest models they have available, right? First, we're going to go through a bit of like an introduction deck with the slides, just to get some theoretical foundation. It's going to be quite light and easy, digestible. And then we're going to spin up Ollama to show you how it looks like in the CLI. And eventually we'll end up with the use case demo. So we have 2 demos to go through today. So I hope it'll be fun. Why local LLMs? We have like OpenAI, we have Gemini, we have AWS. All these are the big tech players. And have you seen they have really powerful models? They have very good and accessible APIs already, as we've gone through from day 2, 3, and 4. So it's already really quite accessible. But what's the advantage of using local LLMs? I would say first thing is, if your institution or business values privacy, then local LLMs is the way to go, because that's a way for you to encapsulate and keep all the information flow within your own ecosystem, right? If you need to access things offline, you can run local LLMs on your own hardware, and there's no need for any internet access. If you have the necessary hardware already, you have a pretty good GPU, it's actually can be quite cheap, because you don't need to send off requests off to a different provider. You can run everything on-prem. So that might be something that you want to consider. Because I remember there's someone on the previous call who's running things on the edge compute. That might be one of the key advantages that you want to consider, local LLMs. And the nice thing is you get fine-tuned control over the model that you want to choose with Ollama. All right. For example, has provided an open source multimodal and multilingual LLMs. So Llama 3.1, 3.2, and 3.3 are the latest LLMs by Meta AI. Llama 3.2 in particular is a very small and quite fast LLM that you can use on the local setting. Okay, so that's the one that we're going to try out today. So nice thing is you have these open source models which you know their weights. You can look into what they're used for, their training data, and you can take them and deploy them wherever you want, on your desktop, on your own servers, on your own cloud, right? Yeah, so at this juncture, since we're talking about models, I thought we can just have a look at the models. So if we go on to that link that I showed earlier, this is the Ollama GitHub, and there's a lot of models that they support already. Okay, so these were the ones that we're talking about, Llama 3.2. It's a pretty small model with about 3 billion parameters and size of 2 gigs. Okay, so you have an even smaller version with 1 billion parameters and 1.3 gigs. So just to quickly take a note here, if you're running this on local, that's the memory and RAM requirement that you need to at least cover. So I say if you're running Llama 3.21b, then you need about an additional 2 gigs of RAM, which is quite accessible actually. And I've seen this run as well on Edge, on Android, on iOS. So you can get these running right in the palm of your hand, which is really, really cool. But just to take a note also, that there are lots of different kind of models already available via Ollama. There's also, I like Gemma too as well, but if you go down to here, Lava is also quite a nice model, which is a multimodal kind of thing. You get a vision plus text kind of understanding as well. So it's already like really accessible and really awesome. We're gonna have a play with this soon. All right. So how do they get these models running locally. You can run them even on some CPU compute as well for the models. The key here is because they've crunched and reduced the size of the models by really great AI research. So they use this technique, one of it is called quantization, where you reduce the precision of the calculations taking place in the model itself. All right. So just in very simple terms, what it means is the number of decimal points and precision that the model uses to calculate its output is much reduced. So you go from, say, 16 decimal points to 4 or less with higher level of quantization. Okay. So the benefits here, as I said, is get a smaller model, you get it running on less compute, it's cheaper, it's faster. And the nice thing is that you don't have any network latency. So no API calls to the cloud coming back, it's all running locally. So that's a huge benefit there. So today we just want to contrast, how you guys have been sending API calls via the SDKs to different big tech providers. So on the right side, you see the gray part. So I just want to illustrate here that what happens when you send a prompt in your browser, that goes to OpenAI. And of course, that prompt goes into a LLM where you run the API calls. Yeah. But there's quite a lot happening also in the background. These calls are logged. There might be some different processes happening within the OpenAI server that you don't know. It's a private place, so they do have some say on what data you put in. All right. In contrast, in the blue side, if we're using Ollama, we can run everything locally. So run it on your own compute. So you send a prompt from your computer, it goes into Ollama, and Ollama makes the API call to your local LLM. Then you get that response back to yourself. Okay. So as you can see already here, just illustrating again the differences is there's less latency, of course. Just the distance of it is much shorter, and it's a lot simpler. Yeah. But yeah, just to tie in what we've been doing. So we have like different API calls that you can send off to different LLMs. And Ollama is just another flavor of it. Okay. Okay. Yeah. So I see Subhash has been addressing some questions. Thank you. I'm in presenter mode. Please do highlight if you have any questions you want me to address right now. But otherwise, I will crack on with the GitHub. Okay. If you go on to the AISG7 GitHub, the links in the canvas all over the Slack. You get a nice README, and that kind of walks you through the stuff that we're going to go through today. Don't worry too much about awesome, Thomas. Don't worry too much about the taking notes, writing down stuff. It's all recorded. What we're gonna do is basically, I'm just gonna run through what is in the text here, do a live demo for you guys, and after the call, you can go and test it out yourself. Okay. The main thing we're gonna do is that you need to first install Ollama onto your own operating system. So they have installers that's specific for Windows, Mac, or Unix. Go to ollama.ai, and that will give you the right installer. Once you install it, then you can use the models that you want to choose, run, and send the prompts. Okay, so we're gonna try that out. So I have a basic terminal here. It's gonna increase the size so it's easy to see. So if you install Ollama correctly, you can access the CLI. I think on Mac as well, you get a nice tiny icon that you can access in the taskbar. But I'm using Windows Subsystem Linux. Okay, so if you do Ollama spell, you see that it's already running in your CLI. So what you should do is we want to send like basic prompts at the moment. What I do is you can do Ollama pool and the model name that you want. Okay, so for example, if you want Ollama pool Llama 3.2, if you do that, that will download the Llama 3.2 server model from the server onto your local machine and store it there. Okay. So once you download that, I've done it already, but when you do it, you can see the progress bar. I've done it already. Once you've done it, you can see it stored. Ollama, what's it? List. Oops. So I need to do Ollama serve first. So that will start the Llama server. Just give me a second. So I have the server running on this tab here. Let me clean this up for you. Okay. And if we do Ollama list, that will show you the models that you've already downloaded. Okay. So I have Llama 3.2. That's the 3 billion parameters version. And I also have Gemma 2, which we're gonna test out. So maybe we can just try Ollama. Okay, Brian says, I had to use Ollama run as well. Yeah, so I think it depends on the system. This is how it works for me. But on the docs, it just says, just go Ollama run your model, and that will already download the model and serve it as well to get a 2-in-1. Yeah. But I think because I'm using a virtualization on Windows, that's kind of a bit different for me. But we can do Ollama run Llama 3.2. And that will begin starting up the server for Llama 3.2. Yeah, there you go. So you go into here. This is my Ollama server. You can see that it's already loaded in the model. You can see the weights and all that stuff. Yeah, and then you can send your prompts that you want to do. Okay, so we can ask it, what do you think about AICamp? And how is the AI immersion study group going? So this is all happening locally. It's pretty fast. As you can see, it's running completely on my compute. I don't even have a GPU, and it's working well. Yeah, so I say AI camps are popular, increasingly popular, and great place to learn about AI. That's sweet. So if you go back here, you can see that it's actually running here. Yeah, and it's sending the post request and API calls within my device itself. Okay, so any questions at this juncture? Like, does Ollama allow calls from Jupyter Notebook? Yes, actually you can connect it. So Tibor has saying he's tested it on IDX as well. And yes, you can use Python frameworks to connect to Ollama. There's lots of ways to connect to Ollama really. So I'm going to use Python as well in one of the demos. So I've tested this. This is a model that's fine-tuned for Japanese to English translation. It's based on the Gemma 2 model that was released. Gemma 2 is actually pretty good for learning and translating text because it's trained over 100 languages. But this is fine-tuned as well. So just to take note here, what are these parameters right at the end? 2B means there's 2 billion parameters. Dash instruct means the model is also additionally fine-tuned to receive instructions that's within the chat setting. And Q8 here means that it's quantized to 8 bits within each calculation, right? 8 bits or 2 bytes of memory with each calculation. Each weight is compressed in that sense, all right? So let's run that. So, run this. Yeah, I can pull out this nifty thing here just for fun. So you can see it's really using up my CPU. And as we do the translation text as well, you can see the compute going up. Okay. So here, let's kick off. So I'll say, please start English to Japanese. Sorry, Japanese to English translation. This says okay, we're ready. So if you're in a pinch, you're stuck in Japan somewhere, you don't have internet access. This might be a nice way of doing it. So I've just got a Japanese news site here, just a random one. I think it's called Asahi News. And say I can't read Japanese at all, I need some help there. You can run this all on your own, okay? And the nice thing again is that, all this is private, so the big guys don't get your data when you do this, yeah? So we can copy this text. Gonna paste it here. So sucker wall Japanese text, I really don't understand, what is it? Press enter, and that will start the translation process. Let's bring this up. Okay, so it seems to be some sort of news article based on New Year's Day in Japan, right? And you can even ask it to summarize this text to one sentence. So it kind of looks like a pretty decent LLM. So I say, the author reflects his reaction towards New Year's Day in Nago. Whether it's excessive or not is part of societal issue. So yeah, pretty decent, I would say. Given the kind of trade-offs that we've done on compute and also precision, I think it works pretty well. And you can kind of find like quite nice use cases for it. Yeah. Okay. So that's it for the Japanese English translation. We're gonna do the other demo as well. Let me see if I'm running short on time. No? Okay, great. So I'm gonna bring up the GitHub again. Yeah, so that was this whole section here. You do Llama, pull and run. And we have done this one here. So case one demo, pretty simple. Yeah. Okay, so we're gonna go to number 2, personal assistant demo. So try to make this fun. And we're gonna be running a secret system within the Batcave. So assume the Batcave has no internet access, you're a superhero, and you can't leak your information out to the bad guys. Yeah. So this is a nice way of using local LLMs. So if you're FBI or CIA, maybe you want to consider this. Be a perfect sort of use case for you. So get rid of that. So I'm going to keep my Llama server running and get my code up. Here we are. Okay. Hope that's okay for everyone. So I'll just focus on the folder structure for now. So if you go on to day 5, in the GitHub repo, you have this code here, which we're going to run. And then I'll just sort of run through the folder structure for you. So what we're going to do here is basically have a document, or you can have a list of documents that you want Ollama to encode for you for your own use. Say if you have like a personal medical condition that you don't want to disclose, you need privacy on it, you can store your private information on your own servers and use your own local LLMs, or any sort of private sensitive information, say financial information, insurance information that's highly quite sensitive. You can store this and use Ollama for your own use cases. Yeah. So what we're going to do is have Ollama and Python connect to Ollama. We're going to use a library called Llama index, and it's going to get Ollama to read in the document, and we're going to test whether it understands that or not. Okay. All right. So this is the code. You want to have these installed. So we're going to use Llama index for this, and I'm going to have the Llama index and Ollama integration used here. So if you're on Jupyter as well, you can use the same packages. I think someone's asking earlier. You can do this on IDX as well. Yep. So make sure you install your requirements and your pip packages before running this. I've already installed it, so I won't repeat that. Yeah. So I'm just going to run this in the Python repo below. Okay, so we're loading our packages in. Going to import Ollama. And here in this first line, there's a directory reader that's going to read in all your documents in a folder. Uh-oh. Ollama documents that does not exist. I think it might be in the wrong folder. Here I go. Oh man. A5. Debugging on the spot. Always fun. Meta. Llama. Source. Okay, that should work. Okay. So here we're gonna set Ollama to connect to the Llama 3.2 model that we have earlier. Okay, I'm gonna give a slightly longer timeout so that it can use enough compute and generate the response that we need. And we also want to have Ollama embeddings as well. And embeddings is the one that will process your documents into a vector format and store it for recall later. Okay. So this is going to take a bit of a while, and it's going to go through the documents that folder. So you can have more than one document in the folder, and it's going to go through that sequentially. Going to save it into local embeddings. Yeah. Okay, so that's done. Yeah, awesome. We are gonna now make the embeddings into a query engine, and we can send it questions to answer. Okay. So here I'm gonna ask Ollama and Llama 3.2, what's the latest valence doing? And this is gonna take a while. I can pull up what Ollama is doing in the background. So you can see in the background, it's really running and chunking through the embeddings, processing it, and running it through all the 3 billion parameters in Llama 3.2. Okay, it does take a while because I don't have a GPU, but if you do have, this is pretty fast. But we can get this in, I think, a minute or so, right? So once we get a response, you can always go back to the document as well to see if Llama's answered it correctly. There we go. You can print its response now. Okay. So here it says, the latest villain intel includes Scarecrow, who is Jonathan Crane, developing toxins with hallucinogenic and mind control properties. Using the East End, we have Two-Face, who is forming an alliance with Penguin to control the underground weapons trade. Riddler seems quite quiet, but he seems to be at Gotham University. Okay. Dubious whether that's correct or not. But what we can do is go to the secret documents here to verify that. Yeah. So I've like some other random information just to kind of mess around with Llama. Here, look. So if it's picked up just this section here. Almost word for word, but you know, pretty nice for a document search. I have to give a disclaimer here that it's not fail-proof, and if you ask it really tough questions, it might not perform as well as like, the bigger models. So you need to have a nice balance between the trade-offs between model size, complexity, and also the results. Yeah, I think that kind of concludes today's demo. Really, really simple. I hope you guys have fun with it. Go ahead and build something fun out of it. I'm also going to be building a Ollama to Android integration. Hopefully I can release this by day 7. But that'll be like a special extra bonus for you guys. All right. And I'm going to share the code too if it works. So just some tips here before we end. So when using Ollama, the good thing is you can choose the model that you want, and always choose the model that's appropriate for your size. What I do is go from the tiniest model and then work slowly outwards. So if you try the tiniest model, it may not be like very great performance. You may miss stuff, or you may get confused with your because of the reduced context window, or just the size of it is just limited. So you can work your way up to larger models from there. Yeah. You can try out with different prompts. So this is kind of segue into day 6, which will be about prompt engineering. Go look up promptengineering.ai. That's a nice place to start. And then try different models. You can test as well on the image recognition side of things. It's really fun. And also test out different quantization, as I mentioned. So quantization, you have like Q4, Q8, Q16, or FP16. These are like increasingly complex. You want to play around and see, like, again, that's a trade-off. You have like highly quantized models. Performance might drop. Might or might not. As you see earlier, we have a Q8 model, and it works pretty well, right? And yeah, just have fun. Enjoy the latency and the speed.